All right, let's dive into something pretty incredible today. We're going to talk about our planet literally, and I mean literally, reshaping itself right before our very eyes. We're talking about an entire continent splitting in two, and the slow, inevitable birth of a brand new ocean. I mean, just really try to picture that for a second. You walk outside, coffee in hand, and there it is. Your first thought might be, okay, that's a huge sinkhole, or maybe it was a big earthquake. But in parts of Africa, a crack like this, well, it isn't just a local problem. It's a sign of something much, much bigger. Because believe it or not, that's what's actually happening. This isn't some sci-fi movie plot, it's real-life geology in action, and it is fundamentally redrawing the map of our world as we speak.
So, let's get into it. That massive fissure we're talking about, it isn't just a one-off event. Nope, it is the most visible, most dramatic part of a geological process that has been unfolding for millions and millions of years.
The whole thing is called the East African Rift System, and I love this analogy of a geological zipper. For about 30 million years now, a force deep, deep within the Earth has been pulling Africa apart, basically unzipping the continent right down its eastern side. Now, to really get how this is happening, let's do a quick refresher, kind of like Geology 101. The ground under our feet, it's not one solid shell. It's more like a giant cracked eggshell made up of these huge puzzle pieces we call tectonic plates. And these plates are always on the move. They're floating on a hotter, gooey layer underneath, and they're constantly crashing, grinding, or pulling away from each other. Okay, so the East African Rift is this super unique, super active spot because it's what geologists call a triple junction. It's the exact point where three of those massive puzzle pieces, the Nubian, Somali, and Arabian plates, are all pulling away from each other at the same time. And as they pull apart, the continental crust between them gets stretched out, thinner and thinner, kind of like taffy, creating these deep valleys and sparking volcanic activity.
And you know, this isn't just some slow, invisible process that you can't see. Get this. Back in 2005, a crack 35 miles long ripped open in the Ethiopian desert in just a matter of days. That event was a huge wake-up call for scientists. It showed them that this rifting doesn't always happen gradually. It can happen in these massive, violent bursts. We are literally watching a continent fracture in our own lifetimes.
Okay, so we know what's happening, but let's dig into the how and the why. It turns out it's not just about these giant forces deep within the Earth. There are actually some surprising factors at play right on the surface that seem to be helping things along.
And here's a twist that I bet you didn't see coming. Some scientists have recently uncovered evidence that changes in our climate might actually be speeding up this continental breakup. So you gotta ask, how on earth is that even possible?
Well, let's break it down. It goes something like this. As the climate in that region gets drier over time, these massive ancient lakes, they start to shrink. And when all that water disappears, you're lifting an enormous amount of weight off the Earth's crust. It's kind of like taking a really heavy lid off a pot. With that pressure suddenly gone, the faults deep underground can slip and slide past each other much more easily, which actually accelerates the whole rifting process.
But at the exact same time, there's this other major force at work from way down below. A gigantic column of scorching hot rock, they call it a super plume, is rising up from the Earth's mantle. Just imagine a giant blowtorch pushing up from underneath, heating the crust, making it thinner, weaker, and even easier to break. It's a geological 1-2 punch, really.
So you've got this pulling from the sides, the pressure being eased from above, and this massive push from below. What's the end game? What does the future actually look like? Well, let's fast forward a few million years and get a little sneak peek at the new world map that's being drawn as we speak.
Eventually, that rift is going to get so deep and so wide that it drops below sea level. And when that finally happens, the waters of the Indian Ocean are just going to rush in, flooding the entire valley. And the result? A brand new sea, splitting a smaller African mainland from a giant new island. And this has some pretty wild geopolitical consequences, right? I mean, look at this. Parts of what we know today as Ethiopia, Somalia, Kenya, and Tanzania will break off completely and form this new island. And in this crazy twist of fate, countries that are completely landlocked today, like Uganda and Zambia, could suddenly find themselves with brand new coastlines. Imagine that.
Now, this is all incredibly exciting, but let's bring this amazing story back into perspective for a minute. It's really easy to get carried away looking at these future maps, but it's super important to understand the kind of time scale we are really talking about.
So while all of this is happening at what geologists would call record speed, you probably shouldn't start buying up that future beachfront property just yet. Scientists figure it'll take about 5 to 10 million years for this new ocean to be fully formed.
So what's the real takeaway here? It's this. We live on a planet that is constantly moving, constantly changing. The ground beneath our feet isn't static at all. And what is just so mind-blowing is that, thanks to modern science, we actually get to witness one of the most fundamental geological processes there is, the creation of an entire ocean, as it happens.
And that leaves us with one final thought to chew on. Knowing everything you know now, would you want to live there? On the edge of a continent that's actively splitting apart, right on the shore of a brand new ocean being born? It's an exciting and maybe a little terrifying thought to end on. Thanks for tuning in.